So can we pretend that we're in an elevator and I say to you, Keith, what do you do?
Well, I'm in charge of the quality and engineering group, so we have the control of how to make these things right. These are very expensive alloys. We have selling prices on some of our alloys over $100 a pound. If you screw this up, it gets very expensive very quickly.
Yeah.
And
So
we do a really
you don't
good
do
job.
that. You don't screw
We don't
this
do
up.
that very often.
No.
No, we do a pretty darn good job of providing a very good product. We have customers we've had for decades and decades that just swear by our material.
Yeah.
It's very formidable and it does a great job in service.
But R&D then is really...
A very strong part. We've been inventing alloys since Elwood Haynes started in 1912. When he got the patent, he opened this company, and we still make today a stellite 6B alloy. It's the only wrought stellite that's made in the world, and it was invented in 1913, and we still make it today.
And what is that used for today?
It is a very wear-resistant alloy. Probably the single biggest application is chainsaw tips. For commercial chainsaws, this has so much wear resistance that instead of using a bearing, they just make a strip of metal around the tip of the chainsaw, and the blade of the chainsaw rubs on that and lasts for the life of the blade. The blade wears out before that wear strip wears out. So
1913.
1913.
That's
Isn't that
amazing.
crazy?
As you can imagine, that requires a lot of power to take something that's solid and get it to 3,000 degrees.
Yeah.
We will utilize as much electricity to produce one heat, which is roughly 40,000 pounds, as the average household would consume annually. So we'll typically produce about 160,000 pounds a day out of this melt shop, which is the equivalent of 4 houses over the course of a year.
Wow. 10,475 pounds.
So it's a big boy.
Yes. Well, this is not the biggest. The biggest we melt on the flat side is around 15,000 pounds.
Yeah, 14.5, 15,000 pounds.
Oh, really?
So
how much bigger is that? About the size of this whole thing?
Well, that's going to be a little bit wider. That's
Wider.
about 37, 38 inches wide. That one's going to be about 47.
Wow. Okay.
So in a steel mill, you'll see ingots that are 50,000 pounds or bigger in one piece. Or they'll do a continuous cast, 100,000 pounds. For these alloys, we have so many different elements in it, they cannot tolerate this big, huge cross-section. They'll melt in a way that you cannot recover it.
Okay.
So there are real limitations in what we can do from the metal side. So this is about as big as we can go thickness-wise on the electrodes. We can go wider though.
But you're just that thick.
Yeah.
Okay.
And some of them have to be even thinner.
Okay.
So some of these, this is 9 or 10. This one's 9, right? So 9. We have some that are only 7 inches.
Okay.